So we're going to implement the search, insert, and also some of those traversing algorithms. So here we have our first class that we have to implement, and that's going to be our basically my binary search tree, right? So that is the one that's going to maintain everything. But also we know that this is going to be kind of considered as a linked list, and so we need 3 nodes in it, right? So we're going to have another class that is going to maintain our 3 node. I'm going to call that class a 3 node class. Since everything is going to be generic, we're going to start from here. You know, we're making everything the generic type. So it's pretty much similar to what you could see on the slide. And so we're going to follow the same thing. So that's basically, we already have the code. I'm just going to redo it here just to have the whole thing here. So since our class is going to be generic, right, we're going to have that on the top of it, so we have to provide that. And then we're going to have elements that we're going to store of type E as well. And then each node, each tree node is going to have a reference to the basically node in the left and node in the right. So it's going to have the left, so those also has to be generic type, because our node is generic, so we have to specify the type. We can create a constructor to make it easier for us to adding elements into this basically node. And so that's what we're going to do. Our tree node is going to get the element and is going to add it to the node. So it when you're creating each node, by default, the values for left and right are both going to be null, and so we have to maintain the binary search class itself. We have to maintain the children's. So we have to have our here also. We have to have it as a binary search. It's also going to be a generic. So, and it's going to have a root, right? And the root type is going to be my, I'm also going to call this my tree node just to be consistent with the rest of our things we discussed in the class. So our binary class needs to maintain the root. So it needs to know where is the root. I'm going to call it the root. And that also has to be there. So the the very first method that we're going to implement is going to be the add or insert method. So because we want to make sure that we can add elements. So the insert method that provided by the tool, it's going to be returning a Boolean type. So it's either add or not be able to add it. So but here I'm just going to make everything void again, right? So we could also keep it as Boolean. It doesn't really matter. You just have to print things in a in a shape that shows what is happening. I guess I'm going to keep it Boolean, just to be consistent. We could make it void, but then you have to print out if it's something is false or not. Okay, so I'll call this insert. So it needs to get a particular element that we're trying to add into this structure. And then it's going to add it, right? So unless it's duplication. So there are two scenarios that can happen, right? So if there is no element in this list, and that means basically our root is null, and to just be consistent, I'm going to create another method. And it's going to return an is empty, just to be consistent. So with our, previous problem. So if it is null, then we know that this is going to be empty. So here I can check if it's not empty. Then I know the root is not null. So then I have to, check anything. But if it is empty, then that's the root. So we can just also do that, like we always like to do if it's not. So if it's not empty, we're going to add it. But if if it's empty, that's going to be the only one in the list. So it's going to go to the root, right? So we're going to add it to the root. So I'm going to create a note here. Here we're going to describe that this is the only element in the list. The first basically element in the tree. So that's going to go to the root. And so the root now is going to be this new element. And we're done. But otherwise, you have to go ahead and find a location of it. Sorry, it took me a little bit to figure out what I'm doing. Okay, here I have to return. We get to this point where, but so here we need to check if if you find it or not, and we need to start traversing, right? So we need to find a place for it because it's not empty, so we need to find a place for it to add it to the list. Okay, so we need two runners as we described. So we need two runners. We have to keep track of each the element that we are and also the parents of it, right? So every time we need to keep track of the parent because each element only knows who is next. It doesn't really know who is the parent itself. So we need two runners. They're both going to start from there at the beginning. They're both going to start from the root. And so I have my 3 node. That's my current node. That's going to be the root. And it's here. my tree node. Okay, so it's error my tree node. And that has to have this one. Sorry, so we're gonna have this, and then I don't know what is this error telling me. And then we're having our parents. They both can start from root. Doesn't really matter because root doesn't really have any parent. Or we can just start with node, right? Because the root doesn't have any parent. And so we keep going. And so what we have to do next is going to be inside the while loop, right? So we have to keep switching to see if we find the parent correctly or not. So for that, we're going to have the search that keep going. So it's going to check that, making sure that the root is not null. So while the root is not null, we keep going. Or the current is not null. Right? So since we're trying to, we have to do the comparison, right? So in the first thing we have to do, we have to check the element value and making sure that the element is going to be the less than the current element. And so we already have the element, so we check that. So if this is less than the current element dot value, if it's less than that, then I know that I have to go to the left side. So the value of the parent is going to become now the current, and the value of the current is going to be the current dot left. So we have to go to the left side. But here we have a problem, and we'll have to see what is the problem. I'm going to talk about it. Let's just write this here. Else, if the value or the element is less than or is bigger than the current dot element, then you have to do this exact thing in the opposite way, and we go to the right. And if it's none of these, then we have to return false, right? That means that we have the duplication. Now we have an error here, and the problem with error that we have here is that we're having elements and we're comparing two elements with each other, but these elements are type of E. So we can't just write, we can't just compare them like that. We need a method to do the compare. So we have to implement a method here. But then what method can do that? If you remember when we're talking about the interfaces, and we talk about some interfaces that are already implemented in Java library. And one of them that you also had in one of your homework assignment was the comparable interface, right? So the comparable interface is going to provide a method that is going to be basically compare two methods. And that's going to help us to comparing two objects, even though those two objects are not, we don't know the type of them at this point, because if the type is, that E type is a comparable type, then you can use the comparable interface, and then you can use the basically the concepts that we learn about it in the interfaces, right? So but that should be the case. That means the E, that type of EE, that should be a type that it does have the comparable in it. Now the question is that how I know if this is true, if I have that, right? So that's going to be the question that we need to ask ourselves. So for that, and to making sure it's going to work correctly, the only thing we have to do is to going up here and say that the E type, whatever type of the E is, has to be, and by has to be means, or is a, and comparable is a Java type. So we can add T here because, yeah. So what this sentence means. So if you remember